According to the passive sign convention, whenever current enters a resistor, the terminal through which it enters is marked as positive, and the terminal through which it leaves is marked as negative. This is pretty simple, straightforward. The one thing that you need to understand is that whenever we have an impedance, a resistor, we always encounter a voltage drop. Whenever we have a load, we encounter a voltage drop. There is no scenario where you will have a voltage gain with a resistor. Okay, this is maybe very obvious, and sometimes the most obvious things are the ones that basically can cause a little bit of confusion. But the takeaway over here is that whenever you have a resistor, current is passing through the resistor, it will always result in a voltage drop. Okay, and the terminal through which the current enters the resistor is the positive terminal, and the current through which the terminal through which the current leaves is the negative terminal. Now, resistors are easy because we also have an understanding that there are heat losses, I square R losses, so the voltage is going to drop. So that's fine. Where things become tricky are the voltage sources, okay, the power supplies. And we have this understanding that a voltage source is a power supply. So it is going to boost the voltage. A voltage source is a power supply. So it should result in a voltage gain. It should result in a voltage rise. But that is not always the case. What it depends on is the direction of current. Okay. In what sense? Well, if the current is leaving the positive terminal of a voltage source, please listen carefully. If the current is leaving the positive terminal of a voltage source, then only it is a voltage gain. Does it make sense? Only if it leaves the positive terminal of the voltage source, then it's a voltage gain. Now, the opposite is true, and you don't need to memorize both scenarios if you just understand that the voltage gain is encountered only when the terminal of the battery is pumping the current, the positive terminal, i.e. the current is leaving the positive terminal, then it's a voltage gain. Then the opposite is true. What if the current is actually entering the positive terminal? Then it's a voltage drop. Now, this scenario is the tricky one because by default, as I told you, our intuitive sense is that power supply, voltage source, always voltage gain. Okay. We typically don't comprehend the fact, generally speaking. I've noticed a lot of students make this mistake. And this is one of the things that I hammer again and again in my electrical and computer exam preparation program and the PE power exam preparation program, that please take some time to understand the passive sign convention. Because when you're writing the KCLs, okay, nodal analysis, when you're writing the KVLs, when you're doing the match loops, when you're doing the loop analysis, this is so easy to miss. If you start collecting the voltage gains and voltage drops just randomly on ad hoc basis, collecting, mixing and matching them without having a proper understanding of whether it's really a voltage gain or a voltage drop, then your equations are going to be incorrect. Okay, your equations, when they are not talking to your assumptions, that makes a lot of a problem. That results in a lot of points that are lost on the exam. And circuit analysis, I tell the students always, is that it's a deceptive section. You can be making progress solving a circuit and then thinking that actually I'm on the right track. But if you're not paying attention to some of these fine details, the subtle details, you can end up making mistakes. Okay. Another comment that I like to make about KCL is that students often ask me that of all the circuit analysis techniques that we have Thevenin, we have mesh analysis, we have KCL or the nodal analysis, we have superposition, we have Norton, we have source transformation. What is that one circuit analysis technique that I can always rely on and that will always do the job for me? Now, There are certain scenarios where KVL, your mesh analysis, can be helpful. There are certain scenarios where even superposition is going to be helpful, source transformation, and sometimes we use a combination of these. But based on my experience and teaching the students and what sticks with the students more easily, I've come to realization that KCL is the one technique that if you can master it and become proficient, it will always get you out of the trouble. Okay. So KCL, whether you're doing circuit analysis within Norton theorem because you have to find ISC, whether you're doing circuit analysis within Thevenin theorem because you have to find V equivalent, V Thevenin, whether you're doing circuit analysis after doing source transformation, okay, converting a voltage source into a current source, whether you're doing circuit analysis while using superposition, if you've turned off all the sources and there's only one voltage source or a current source that you're using, in all of these scenarios, I would say the most integral technique is obviously Ohm's law, upon which all of this is built on. Because when we do the circuit analysis problems, KCL problems, for example, we use Ohm's law over there as well. But the one technique, if you can invest time and if you want to use resources and do practice, I would suggest that KCL should be that technique. Okay. And if there's one thing you remember from this session, is that investing time in understanding KCL is probably going to unlock 80% of circuit analysis problems for you. It doesn't mean that the other techniques are useless. It doesn't mean that the other techniques are ineffective. In fact, in different cases, you can solve a given circuit more quickly, more efficiently using some of the other techniques. But if you want to keep things simple and always, fall back on one technique, then in my opinion, my recommendation is KCL. Okay. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and PE power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and PE power exam preparation programs, please visit my website, studyforfe.com.